Thanks, everyone. I'm Elijah Newren. I work at GitHub. A few years ago, I gave a talk on the new Merge backend, but I just barely lightly touched on the new features, and I focused on the performance and the things I did to discover the performance optimizations inside. I'm going to kind of flip it this time and only lightly touch on the performance and focus a bit more on the features. So first of all, I'm going to start out and give a little bit of background. Some of you might be wondering, what is the Merge backend? Git has a concept of pluggable merge strategies or algorithms. So when you're calling Git Merge, you can pass the SS flag and pick one of the various ones. There's a number that are built in. Users can also create some, though I don't think there have been too many of those. One interesting thing about this command line, well, here's an example. So the old Merge backend, the default one was called recursive. And so you just pass this kind of command line flag. An interesting thing about Git parser is that the space after the -s is optional. And I'll tell you why that matters in just a second, but I named the new merge algorithm, it was an acronym, ostensibly recursive's twin, because it was meant to replace recursive. It was also named that because I just found this really amusing to have this command line. You don't actually have to call out this new default merge strategy because it's the default. So you get it just when you go ahead and run. And it's not just the merge command that uses this merge backend. It also powers things like rebase, stash, cherry pick, and so forth. First kind of features I want to call out a little bit. I put in quotes because there might not be what you think of in terms of features. But I actually got started on the whole thing because of correctness. I made lots of modifications to the old default backend, and I eventually got to the point where there were a number of edge and corner cases that were really difficult to fix with the existing data structures. And I figured out what kind of data structures I wanted in order to be able to go and get those appropriately fixed. And now this new backend passes all the tests the old backend did, and a few dozen tests that the old backend fails. I said something similar a few years ago when I talked about performance, and I think the universe takes that as a challenge. The very next day, someone mailed the mailing list with, here's an issue on the new merge backend. So I'm expecting another one of those emails to come in tomorrow, now that I'm saying this again. But we fixed all of those up, so it's an improvement on correctness. The new merge backend is probably most well known for its performance. There are various cases where it gets some pretty eye-popping improvements. And the main reason for that it came from a few little discoveries. One, renames are really important to merges and being able to compute the merges, but not all renames are. Some renames, it doesn't matter whether you've detected them or not. The merge result is going to be the same. So don't bother detecting those. And statistically, most of the renames don't matter. And since rename detection is quadratic, order n squared, being able to reduce that number n can really speed things up. I also added in something that changed it from the order n squared to linear in a number of cases. Can't do them all that way. And then those combination of optimizations allowed another one where we can avoid recursing into directories a number of times. And again, I covered that in a lot more detail in a previous presentation a few years ago. But the big upshot was that the bigger the repo, the greater the speed up from this new merge backend. If you want to learn more about those details, you can see my talk from a few years ago or look up the blog post that I wrote on the topic. I've got a sequence of 6 different parts, but just Google for optimizing Git's merge machinery, and you'll be able to find those. Then I want to go into some of what you might more normally call some of the features associated with this new merge backend. First of all comes repository subsets. There's different ways that you might subset a repository. The most well-known perhaps is shallow clones, where you only get a few commits of history, but you have a full checkout. That one's perhaps the least interesting, at least as far as what I'm concerned with here. Another way of subsetting your repository is keep the full history, but just have a subset of the files checked out, something known as a sparse checkout. In addition to having your working tree be sparse, you could also think of having your index file be sparse. Both of these are things that didn't work well with the old merge backend. The old merge backend had working tree update code littered all throughout it, and trying to change that so that it wouldn't modify the working tree basically required a complete rewrite. And the most fundamental data structure to the old merge backend was the concept of an index, and in particular a full index. So it really didn't work well with the idea of what would be a sparse index that exists now. But also because of the fact that it was dealt with just relevant renames, that meant when it came time to do a merge, and if you were in a partial clone, there were far fewer blobs that it would need to download in order to complete that merge or rebase or cherry pick operation. Another feature came in trying to do an X-ray or viewing the details about what happened inside of a merge. So I'll give a simple example. Let's say you've got a repository. You've got a number of commits on both the main and the feature branches, and you want to merge these together. So you check out the main branch, you run git merge feature, and Git starts to create a merge, but it runs into conflicts. So you have to go and edit those conflicts, fix them up, and run git merge -- continue. But let's say that you haven't fixed all those merge conflicts yet. You've only fixed some of them, and you've made various changes. And you want to see what changes you've made. The obvious choices for that with git diff that you might expect, if you run any of those, problem is that combines changes that were made by the merge command with the changes that you made. If you want to just see the changes that you've made since the merge stopped, then you need something else besides these. And that's where we created the git diff auto merge command. That might look like a placeholder, but auto_merge is literal text. And that works even if you're in the middle of a rebase or a cherry pick or a merge, any of those. It will let you see what changes have you made since Git stopped and gave control back to you to resolve conflicts. And if you think about, you can use the same basic idea to say, well, what if you've already created a commit, or what if someone else has created a merge commit? Can you see what they did to resolve conflicts? For that, slightly different command, git log -- remerge diff. So I'll give a couple examples of each of these. If you run git diff auto merge and you're in the middle of resolving a conflict, you might see some output that looks kind of like this in your terminal. So you can see in red that you've removed the conflict markers on each of the sides, and you also removed the line that existed on both sides of history, and instead replaced it in green with a new line that was a combination of the previous two. And as I mentioned before, that you can use this git diff auto merge even if you're in the middle of a rebase, cherry pick, or a revert, as well as if you're in the middle of a merge. And if you want to see someone else's conflict resolution, in addition to git log -- remerge diff, there's also a git show -- remerge diff. And you'd see very similar content. One little difference from the previous slide is that if you're in the middle of resolving the conflict, odds are you still have the git merge output. And so it could tell you about various conflicts that existed. Whereas if you're looking at someone else's, you no longer have that output of the various things that it said. And if you have a conflict type that isn't representable with conflict markers, binary conflict, files differently renamed, different modes or whatnot, then having that extra little information about what kind of conflict existed is helpful. So that is also provided at this point. But the remerge diff flag only works on merges, not on commits created by rebase, cherry pick, or revert. Some of the newer features, first of all, one of them comes with a command called range diff. How many are familiar with range diff? By show of hands? Small subset, okay. That's what I was probably guessing. So I'm going to go over it briefly, just what it does. But the basic idea is if you've got a set of commits and they've been rebased, then you want to see how the old set of commits compares to the new set of commits. And so when you run git range diff with the appropriate flags to let it know what the two ranges are, then it'll give output that looks something kind of like this. And what it shows is that it was trying to compare them and said that the New commit number 1 didn't have a good match in the previous set. That's all the hyphen lines. So it's a new commit that exists in your new set. And then the next commit, code B and caboose from the 2 were the same commits, basically, across the 2 sets. The next set of commits, foodball and decaf, those commits were similar, but there's differences between them. Someone's gone and modified those as part of the rebasing. And I'll come back into those details a little bit. And then finally, the last commit existed only in the old set of commits, but not in the new set of commits. In these differences between foodball and decaf, you see that the commit message has been modified, as well as the text that was added to the file has been modified. So that gives us a little bit of what range diff does. But what if you had a merge which resolved both syntactic and semantic conflicts, and you rebased that instead of just rebasing regular commits? For range diff, by default, merges are skipped entirely. And partially the reason for that is that when you do a git diff on a merge or a git log-p on a merge, it doesn't show any kind of diff inside of it. By default, we don't show diffs for merges, so you need to turn that on. And there are various flags inside of Git for wanting to look at a merge commit, but most of the ones that existed previously just don't work well with range diff. And I'm not going to go over all those details, but there's a bunch of details for why the various other kinds of diffs don't work well. But this new remerge diff flag that we added to log and to show works really nicely inside of range diff. So Johannes added it there actually. And in this one you see, for example, and range diff is sometimes a little bit hard to read because it's always a diff of a diff. So you've got this nested iteration and it takes a little while to get used to. But I'll walk over one real quickly. The first column tells you, was it the old commit or the new commit you're looking at? Minus means the old commit, plus means the new commit. The space means both of them did the same thing. So the first line says that both lines removed this print high name statement. Second line says that the old commit removed this conflict marker with the SHA starts with 3BD, and then it added a slightly different print command, print high name plus punctuation. Whereas the new commit removed a slightly different conflict marker and then added a print howdy name plus punctuation. So there you get to see that they resolved the conflict a little bit differently. Additionally, the new commit made an additional change that what didn't exist in the old one. And so you get to see that other additional change. It removed greet Bob and added greet Bob with a period for the punctuation. Next feature I wanted to talk about was Git Merge tree. So one of the problems with the old default merge backend, as I alluded to earlier, was the fact that it required a working tree. It would always write to one. And that made it problematic in order to do various additional things you might want to, particularly if, let's say, you're running servers, GitHub or GitLab. You basically couldn't use that merge backend. You'd end up using something else instead, like libgit2. But then you run into some problems in that users will report that libgit2 doesn't give you the same thing that if they tried to just run git merge to the command line. They got different results. So after we got this new merge backend, added git merge tree to give you the ability to go and merge any two branches or any two commits without touching the working tree or index and not needing those to even exist. Simple command, git merge tree, you give it the two things you want to be merged. It responds with the hash of the tree that's merged and conflict information if there's any. So for example, you can say git merge tree, the hotfix branch with origin/main responds back, says here's the merge. Or give it any two random commits. In this case, there'd be conflicts, and it provides a whole bunch of extra information about what those conflicts were. Similar to merging, we might want to be able to do rebasing and cherry picking without having a working tree or index. There's a new command called git replay that allows that. with two primary flags, either dash dash onto or dash dash advance. So some examples, if we want to transplant the commits from version 3.6 up to hotfix onto main, then we would use one of these two commands. And you'll notice that the arguments are the same other than just the flag of onto or advance. And the difference between these two is which branch should be updated to track the transplanted commits. If you want all the transplanted commits to be tracked by hotfix, then that's a rebase operation. Use the dash dash onto. And if you want main to be updated to include all those new commits, then that's basically a cherry pick operation. You use the dash dash advance flag. And then there's some features that don't exist yet in Git that I've been working on, wanted to share with you. But as a little bit of a warning, there are various reasons I call this just a demo. It's not ready yet. It hasn't been reviewed by other Git developers, and some of the features maybe the other Git developers don't even like, so no promises that it'll go there. And I will carefully try to avoid any bugs that I know happen to exist right now. So on a previous slide, I mentioned that the remerge diff flag only works for merges. And the main reason for that is with merges, we can know what was previously merged and just remerge those. But if you're doing a rebase, we don't have any information about what that commit was a rebase of. That's not recorded anywhere. With the cherry pick, we often don't have it either. If they specify the -x flag, then it would be inside the commit message as long as they didn't modify it. And similarly with reverts. And since Git doesn't track that information, there's no way for me to go back and say this is how it differs from what a rebase or a cherry pick would do right now. But if we provide some kind of hint to Git about this, then we can make it all work. So inside the Linux kernel repository, if we write out, hey, this commit is a cherry pick of this other commit to some auxiliary file, then we can say git show some new command line flag dash dash remerge diff picks, give it that file name, and then say I want to look at that file and see how does it differ from what a cherry pick would give me. So if I look at that, I see this Linux kernel commit, scroll down a little bit, and I notice that, oh, this user, obviously they are going to remove the conflict markers. They removed some of the old text as well as the text, some text on the other side. So they removed a little bit of text from both sides of the merge, but kept a little bit of text from both sides of the merge, because that's what mattered to them for being able to resolve the conflicts. But in addition, they had to make some other change other than just resolving textual conflicts in order to make it all work. So this gives you a way to be able to look at what kind of changes exist relative to a cherry pick and whether they had to sneak in additional changes or did something else get mixed up. My biggest issue with that one is the UI is just ugly. So if someone has ideas on how to make that a little bit nicer on the command line, that would be great. Next new feature, I talked a little bit about git range diff dash dash remerge diff on a previous slide and how Johannes added that. One of the reasons why that's so necessary is because of what the rebase merges flag of git rebase does. You can use that flag in order to rebase merges instead of just dropping them. But if a merge being rebased has any conflict resolutions, either syntactic or semantic, then with this flag, they're just going to be discarded. And it's dependent on the user to say, okay, you're going to go resolve those again and put those changes back into place. That means that it's really important to go view things again at the end of doing a rebase with this range diff dash dash remerge diff flag to make sure that you didn't lose any important semantic conflict resolutions. But as I mentioned before, this remerge diff allows us to look into merges and see what those conflict resolutions were. So it would be nice to just be able to take those and apply them. And so, do a little demo with that. Not that one. I got my Okay, so first of all, I'll show you the history of this repository. You'll note that the main branch has 4 commits, initial, and then A, B, C, and D. But based off the initial commit, there are these 2 other branches, add caller and add argument, and they've been merged together. And one thing about this merge commit, I'm going to show you what it looks like. Okay, so that merge commit isn't a clean merge. There had to be some conflict resolutions. And there was also some extra changes needed to make it all work together with those conflict resolutions. So now on the right side, I'm going to rebase both of those branches, add caller and add argument, on top of the new main. After I do that, I can look at the new history. These branches now exist on top. And now if I look at this new merge commit that was created, it remembered all those merge conflict resolutions and ported them all over. The next one, feature working on a little bit, reimagining interactive rebase. And several of you can probably guess what this looks like because several of you are familiar with JJ, and Git Butlers looks like is a little bit ahead of this, but trying to bring it to Git. There's a few issues with interactive rebases as they exist inside of Git. One, there's a new language for users to learn, pick, edit, squash, fix up. They get a long list of commits. They might only be interested in going and editing one of them, but they've got to deal with this list of things, which are also in the opposite order that Git log would show them, which sometimes causes confusion as I've gone to explain this to new users. A common issue that hits up is that there are different ways to continue depending on what kind of state problem you run into. If you hit conflicts versus if you're editing a commit and it was clean, you have to use git commit -- amend versus git rebase -- continue depending on which of those 2 states you were in. And if you get it wrong, you can accidentally munge your commits together. New users are likely to do this, and unfortunately, I still do it every once in a while, and then have to go and clean it back up. And I've worked on both the rebase and the merge backends inside of Git. Another issue is that there's no way to back up or nest interactive rebases. Sometimes, because you have this long list of commits, you're like, okay, I want to do this one and this one and this one. You start doing a few, and then you realize I want to go back, and you have to instead finish your rebasing and then go back to the way before. But what if we handled it in a different way? So I'm going to show a few windows. On the left, I'm going to show what the history exists at the starting point. So I've got a few branches that have diverged from each other, and on the right I'm going to show what the current state is. Right now, left and right screen should match. Then in the bottom terminal, I'm going to say I want to edit, let's see, this commit back in history. Okay, and you'll notice that this is basically like a checkout operation in that I've checked out this old commit. And now I can do something like git commit -- amend. Let's change that commit message a little bit. And you'll notice that the commit message changed over on the right side and all the other commits were replayed on top. I can modify some files. Add a new commit, which is now inserted because everything else gets rebased on top. I can then say, oops, I was supposed to split that second commit. Let's go back and edit it some more. See, that commit had 2 modifications, and I wanted that to be in separate commits. So I'm going to undo this commit. Now I've got some unstaged changes. Let's stage some of these. I want this first change staged. Let's commit it. Nice commit message. Fix the typo. Then let's look at that other file, stage those changes, take a look at it. Yep, that's the one that we want. Make a commit message for it. And now we've got that one done, and you'll see also on the right side that we've got that history was rebased on top of all these things. And now I can say, you know what? Now that I fixed these, I want to go back to the top of where that new commit was. So now I'm editing that one, and then I'm like, you know what? I really want this commit B to be a little bit earlier in history and be part of both these branches back here. So I'm going to cherry pick that one. And so now that commit has moved to that point in history. And when you want to be done, you can use git switch or git checkout, either one, whatever branch you want, but checkout and switch are the way you get out of editing mode. So, lots of new features coming and that have come from this new Merge backend. Thanks for your time. Oh, sure, questions. Right. So I want to do the same thing you're doing. It's not implemented. So what happens right now, instead of recording conflict headers, it's going to fail the replay, and now my head is detached and there's no branch on top of it. So it's not ready for prime time or anything yet, but I really like the idea that Git Butler and JJ are both using of having conflict headers stored inside. We'll see what the other Git contributors think about that, but there are definitely problems because then, like someone mentioned with pushing, I want to make it so that I would remove the tree header or something so that people don't accidentally push, because I'm worried about what happens when you push up to all these different forges if that becomes a core Git feature. And then, anyway, various things in order to make sure that the server is ready to receive those kind of objects and would error out right now if they're not ready to receive it.
So in your example of remerge diff on a cherry pick commit, there was a lot of heavy lifting being done by that file that had some job ones in it, your remerge pick file. So I understand how you would get that from the cherry pick, right? Because it was done with -x and you could copy that information out. How would you get that information for a rebase?
You would have to know it somehow, and there isn't a nice way to grab that. There's various discussions in past years on change IDs. Although the change ID might not be the most recent one that you rebased, it may have been some prior version. I don't have a good way to do it, and I actually have had that commit particular thing implemented for a few years. I didn't have good UI for it, and so I never submitted it. But I wanted to throw it in there as just because lots of different features that exist and are capable. If someone can come up with good UI, then we can upstream it.
On what you were saying earlier about not allowing people to push conflicts, what about if there was something in the header or something that would allow a forge to know that there's conflicts in this commit, and so I might want help from someone else to fix it, right? And so maybe it could...
I think it would be a nice way to be able to share and say, you know what, I resolved the conflicts in these 3 commits, but I need help with these 2. I just want the servers to be ready for it and say, oh yeah, it's acceptable on these branches or something, rather than someone pushing to the main branch something with conflicts.
Yeah, like labeling like progress or something.
Yep. All right, thanks.